in 2013 with a Bachelor's of Science in Geology and a minor in Mathematics. And I went to work for USGS at the Oregon Water Science Center for about 2 years as a computer programmer and a web developer, oddly enough. And then I came to Baylor for graduate school in August of 2015. And my advisor is Dr. Scott James, and I am largely a computer modeler. I used to do a lot of what I would term physics-based modeling, so working with models that have that are trying to simulate natural processes using some type of equation, some type of physics-based equation that approximates the process that we're trying to predict. I now do a lot more what I would call data-driven modeling, in which I take a series of inputs and outputs, or what you can consider cause and effect scenarios, and show the computer enough examples of a cause and effect so that in the future I really only have to give it the cause and it will be able to predict the effect appropriately. So that's most of what we're going to be talking about during this seminar series. Today what I want to talk about is just sort of an intro to just basic computer programming, specifically with Python. We're going to be using Python for all of the programming that we do during this seminar. One, because it's a great open source language and it seems to be the language that most people, both in industry and academia, are adopting. But additionally, because most of the deep learning frameworks that we'll need to do the programming are written in Python. And most people who are doing deep learning have seemed to adopt over to Python, although some people are doing crazy stuff with Julia too, so that's super fun. So what I want to do today actually is just really quickly, I'm going to show you guys where to pick up the files for this seminar. So you should have received a link in an email to this GitHub page. And I don't think that you even need to have an account on GitHub in order to download files. I also wrote the URL up on the board over here if that's helpful. And I will continue to update. Right now I have materials for today here and for the seminar that we'll do in a couple weeks, I think on the 15th. But you can just go ahead and download a zip file of this repository. You can look up how to clone repositories in GitHub also if you're a little more tech savvy. But if that doesn't make sense to you, just go ahead and download the zip file, and that'll be completely fine. So for today, what I'm going to do is I'm just going to go through a couple of sort of basic getting started tips and tricks. And if we have time, I'll show you a couple of demos. Again, I won't be able to run those demos today, but I will be able to show you the code and what the output looks like, and I can explain anything that might be confusing. So do you guys have any questions right now about how to access materials, or maybe what the objectives or what the whole point is of us being in here? Okay, awesome. So I'm going to go through then and do this basic skills talk really quick. And I think I'm going to have to use this keyboard here. Let me make sure. Sorry guys, I'm doing this through a PDF, and my clicker doesn't work on the PDF, so I'm using the keyboard keys here. There we go. Okay, now I just remember which way's which. So whenever I start learning a new programming language, there are a number of basic tasks that I make sure that I understand the syntax of how to use those, or how to do those basic tasks. And those would be reading and writing files, so reading in data, doing something to your data, and writing an output file. Understanding the different data types and different structures within the specific language, and we'll talk about different data types throughout this presentation. You want to understand arithmetic and logical operators, so that would be things like plus signs, minus signs, division signs. Usually the syntax for things like that doesn't change significantly from one language to another, but sometimes there are small variations that you need to be aware of. String manipulation is another really big task that a lot of people overlook. When I talk about string manipulation, what I'm talking about is that a lot of times with your data, you'll have some type of maybe a site identifier or some kind of code that's a mix of letters and numbers, and that's usually a type called a string. And a lot of times what you need to do is, those identifiers might have information embedded in them, like the date that some measurement was made will be encoded in the identifier name. And so being able to go into that name and say, hey, get the date from that is a useful, I would say, utility that I do pretty frequently. So that would be an example of string manipulation, and we'll talk about that a little bit more. For loops and if-else, or what we would call conditional statements, are going to be the primary sort of workflow drivers that you'll use to structure your code. So a for loop is used to loop through a particular operation over a series of elements. So if there's a function that you wanted to apply to every element in a list, you would then loop through that list and apply the function to each individual element. An if-else, or a conditional statement, is how you make a choice in programming, right? If you want to, maybe we're searching for values in an array that are over a particular threshold, right? Or we're doing some type of calculation that we only want to keep the outputs if it's over a particular threshold or qualifies as true for some conditional statement. Then we use an if-else or conditional statement to make that kind of a choice. It's the way that we let the computer know when and where there is a fork in the road in the data analysis and what to do when it reaches that point. So I would say probably 90% of the programming that I do involves this general workflow, which is reading some type of input data, analyzing that data in one form or another, and outputting usually a text file. And what I should add on here actually is doing some type of visualization. It's really, really helpful to visualize your data. And I do have, if we have time, I have a basic plotting demo that we can look at. When you're working with text files, it's important to have an editor that works well for you. I would say most people end up using Notepad++. It's a free editor. It's really easy to use. I think it's already on most of these computers. TextPad and Sublime are other popular ones. I like both of those just as well. Microsoft Word is not a text editor. Microsoft Word can certainly be used to view text files, but often the encodings, the way that things are presented in Word, is much more of what I would call a GUI environment. It's a graphical user interface, GUI, that's pronounced GUI. And it will interpret characters a little bit differently than what you really want to see. And it's not really meant to display delimited data. So when you're working with text files, it would be a good idea to choose one of these other editors to work with, and then use Microsoft Word for honestly nothing, in my opinion. But that's my own feeling. So these are just a couple examples of different things to look for when you're working with text files. So one thing to do before you start reading in the data is to actually just take a look at the file itself and open it up in one of these editors. So these text files are open in, I think this was in Notepad++, but a couple different things that you want to look for. So in both of these text files, you'll see sections outlined in blue, and that's the actual data that you want to read in. Those are the actual numbers that you're going to be doing some type of an analysis on. Outlined in green are the column headers for each of these groups of data. And those are going to be really important pieces of information because you're going to want to be able to point your program or your script towards a particular column of data, right? So those are important to read in. And then you'll notice in this file on the left, there's this big section at the top that's outlined in red. So this file on the left is an example of a USGS, I think it's a groundwater data file. And USGS usually puts these really big headers at the top of their data files to give you metadata about the site, about the file itself, where you can find more information. And you'll notice that the beginning of each of these header lines starts with a particular character. And in this case, it's the pound sign. So USGS uses that as their comment character on all of their text files when they're doing some type of big header, which is really typical for them. And so when you look at this type of a file, you need to think about how to tell the computer which elements of the data or which elements of the text file that you actually want to read in. So thinking about this file in particular, what we really want to tell the computer is skip anything that starts with a pound sign at the beginning of the line, because that's not data. Following that will be some column headers, and following that will be the actual data, right? In this case, with this file over here on the right, I really just have to tell the computer everything except the first line is data, and then we're good to go from there. Knowing the delimiter of your file is another piece of information that you do need to be able to tell the computer. So the delimiter is the character that separates the columns in your data. The probably two most common would be tab delimited or comma separated values. Another really common one actually would be a space delimited file. But when you look at your data in a text editor, for a tab delimited file, for example, when you just look at this data, it's really difficult to tell if it's tab delimited or space delimited. And so one good thing to do is you'll notice on a lot of text editors, you'll see this little key here. It's like a backwards P kind of. It's like the paragraph sign, right? And if you click that button, what it will do is it will show you hidden characters. So when you're typing, you know, there are a number of characters on your keyboard that will actually show up when you type them. But if you hit something like a tab key or enter, that operation won't actually show up unless you have it enabled. That's called a hidden character. So when I enable the hidden characters here, what I see with this tab delimited file is that in between each column of data, I see these little arrows separating each column. And I know that that means a tab, right? At the end of each of these lines, I see kind of it's this little upside down flag, I guess, and that's an enter or a return, a control return line. Over for the comma separated values, I really just see the only hidden characters are the return at the end of the line. Obviously, commas are a regular character that you can see. Do you guys have any questions about delimiters? Okay. So the first data type that I want to talk about is a string, and I mentioned strings a little bit earlier. So a couple of important things to know about strings. A character would be any single number or letter represented as a string. Usually we represent strings with either single or double quotes. It really doesn't matter which one you use. They just have to be the same on both sides. I tend to use a single quote because it's less typing. I don't have to hit the shift key in order to do that. A string would be any collection of characters put together in a single variable. And the space here also counts as a character. So, for example, this string, hello world, is the length of this string is 11. There are 5 letters in the first word, followed by a space, followed by 5 letters in the second word. So a total length of 11. Strings are case sensitive. So this string with hello world written all in capital letters would not be equivalent to this string where I have a mix of capital letters and lowercase letters. I can also represent numbers as strings. So this example here, this 1 surrounded by single quotes, that's a string representation of the number 1. If I tried to do some type of math with a string representation of the number 1, I would get an error. So if I tried to, say, add this to the value 2, which would be an integer, I would get what's called a type error. So type errors are probably the most common errors that you're going to get doing any type of programming. And so it's a good thing to be aware of because it'll make your personal debugging quite a bit easier. That's usually the first thing that I check for. Did I put the data into the function in the type that it was expecting to have? And usually string to integer or float conversions are the primary issue that people tend to deal with. Another common data types would be integers and floats. These are the 2 number types that you will most commonly be using. So a floating point number is really any number that has a decimal point. You can save them with different levels of precision. I think by default, Python does double precision. And basically what that means is the number of bytes or the number of decimal places that are saved in the computer's memory. Single precision would be more memory intensive than double precision is more memory intensive than single precision. The downfall of that is that it does require more memory for storage, but at the data scales that we are probably working at in the geosciences, it really shouldn't be much of an issue. I think that just storing things as floats as double precision is probably completely fine. So you can convert in between data types in Python very easily. So if I wanted to turn pi, or this decimal representation of pi, into an integer, I just apply the integer function around that number, and my output is then an integer. Same if I want to take this integer 1 and turn it into a floating point number, I just apply the float function around the value that I'm trying to convert, and the output is 1.0 instead of the integer 1. Cool. Does anybody have questions about data types so far? Cool. Yeah. So Booleans are a data type that you probably haven't seen very much outside of computer programming unless you've done some philosophy or logic courses, which I actually had to take one of those courses when I was an undergrad. It was one of the like semi-required electives that you have to graduate. And I was so mad, and I had such a bad attitude in that class. And then I started computer programming, and just learning the logic structures in that class had really helped me develop as a computer programmer. And I felt so bad that I went back a couple years later and I talked to the professor of that course, and I said, I don't know if you remember me, but I had a really bad attitude in your class, and I'm really sorry because it really helped me. So it worked out, I guess, for everybody in the end. But so a Boolean is a true or false. Will have either one of two values. It's either true or false. And these are usually the way that you will structure some kind of conditional statement, right? So if I'm trying to make some kind of if-else statement, what I want is if something evaluates to true, so if the Boolean representation of a particular of a particular conditional statement evaluates to true, then that argument will be able to continue. If it evaluates to false, then that code block will not be executed. And we'll look at if-else statements a little bit more later. But this is just a basic table of how true and false statements will evaluate. So if I have a single statement that is true and another statement that is also true, then this entire statement will develop to true. Similarly, if I have one statement that evaluates to true and another statement that evaluates to false, this entire statement then evaluates to false. So these are really good. I actually usually have this sort of table written on a Post-it note that I'll put on my computer, because it's a good way to check through your code and make sure that the code blocks that you want to evaluate or to be evaluated are actually being evaluated. Computers are very, very intelligent, but they really only do exactly what you tell them to do. And a lot of the time, I think when you're writing code, what will happen is that you think that you have communicated a particular task to the computer effectively. You made a mistake somewhere along the line, and what you're really telling the computer to do is something quite different than your overall objective. So it's a good idea as you're building the code to verify which code blocks are executing and when, to make sure that that kind of works out with your implementation algorithm. So the first data type structure that I want to talk about is called a list in Python. And lists are really, really commonly used throughout Python. This would be equivalent to a vector if you had only numerical values in it. The nice thing about a list in Python, and I generally don't do this very often, but the nice thing about a list is that you can have different types within the same structure. So you'll notice in this first example, I have 3 integers and then a string in the same list. And it's perfectly fine to store data that way. Generally, for a lot of the applications that you guys will probably do, for you a list will be a representation of a vector, and you'll have only numerical values within that list. There are 2 different ways to define a list. One, which is probably more popular because it requires a little bit less programming, is just to surround comma-separated values with square brackets. The other way would be to use the built-in list function in Python, which is just the word list surrounding comma-separated values with parentheses. So you can access individual list items using the slice operator. Python calls indexing slicing, if you're familiar with other languages. And that's just done using these square brackets again. One thing that's really important to remember with Python, unlike some other programming languages, like MATLAB, for example, is that Python is zero-based. And so what that means is that the first index position is considered the 0th index. The second index position is considered index 1. The third element is considered index 2, and so on. So in this case, I'm trying to access index position 1 of this list, and I get the element 2 out. So that means that I'm not actually accessing what in my mind would be the first index position, because that's index 0. I'm actually accessing index position 1. Does that make sense to you guys of being zero-based? Yeah? Okay. Yeah?
So lists they can handle strings, integers, and floats?
Yep. You can put anything in a list that you want. You can put a list inside of a list. You could probably put a dictionary inside of a list if you want to get really crazy, but I don't see why you would ever want to do that. But yeah, absolutely. So speaking of dictionaries, dictionaries are really good ways to sort key and value pairs, is what it's called. So in other languages, a dictionary might be called a hash. You might have seen that in, I think Perl calls them hashes. C, I think it's a hash. But basically what this is, it's really similar to JSON notation if you guys do any web programming. But what you have is some kind of a key and then an associated value within that dictionary. So in this case, what I want to do is I want to store the value first name, which I've saved as a variable here. Actually, let's do this top to bottom. So again, there are two different ways that I can define a dictionary. One, a little bit more programming or a little bit more typing with the actual function name, and the other with the curly braces here. This is probably the more common option, again, because it uses just a little bit less typing. So what I'm going to do now is I'm going to assign some variables. One thing I do want to point out, you'll see, and I think I've used it a couple times so far, there's a difference in Python between using a single equal sign and a double equal sign. So a double equal sign suggests equivalency. What it means is that what I have on the left-hand side of the double equal sign is equivalent to what I have on the right-hand side. So that means that I would have two equivalent strings, two equivalent numerical values, or whatever, right? When I have a single equal sign, what that means is assignment. So in this case, what this means is that I am creating a variable that I'm calling first name, and I am assigning the string John to that variable. So now, anytime that I use this variable name in my script, what I'm really doing is I'm using this value that is stored or assigned to that variable name. So in this case, I've defined a couple of variables, first name, last name, and a final grade. And I'm going to create a dictionary to store these student grades. And I'm going to call that dictionary student grades. And you can see the dictionary itself is completely enclosed in these curly braces. So what I want to do is store key and value pairs. So to store the value first name, I'm going to store it under the key first name. Last name is going to be stored under the key last name. Final grade is going to be stored under the key grade. So now, if I wanted to, I could go into this dictionary and I could say, get me the value that's associated with the key first name, and what would be returned is the string stored as this variable. So I don't think I use dictionaries particularly often. They're really good for things like lookup tables, if you're trying to do things like that. I don't tend to store a ton of data in dictionaries, but you certainly can, and I think I have some examples in the demo folder where we do use dictionaries a little bit. It's a good data type to get used to working with. So I talked earlier about type errors a little bit, and that's just a very common scenario that you'll run into. And so it's really important to make sure that all of your values that you're trying to use together either share a type or have compatible types. And so I have a couple of examples here of some maybe operations that you might want to do. So if you look at this first example, what I really want to get is I want to make a string that says the word output followed by a colon and a space and then followed by the number 2. But I need this whole thing to be a string, right? What I have is I have a string variable, which is the word output followed by a colon and a space. And then I have a numerical value 2, which is an integer. So in order to combine these two things, what I need to do is I need to do an integer to string conversion on this numerical value here. So what I can do is I can build this output string by adding or concatenating these two strings together. And here I've converted that numerical variable to a string using this str or string function. This is an internal Python function. Let's see, similarly over here I have two values that it looks like I'm just trying to divide the numerator by the denominator. And Python doesn't want to let me do that because you'll notice that this denominator is stored as a string again. And I have the numerator stored as an numerical value. So what I need to do is I need to convert this string into a floating point number so that I can divide the numerator by it. And so what I'm going to do is I'm going to use this float conversion function here, and I can go ahead and use my divisor in there as well. Does that make sense to you guys? Cool.
Python 2 work, so you don't have to worry about the difference between the division of 2 and 3, right?
Are you talking about working with backslashes or?
Well, just using the division symbol pre 3.0, it gives you kind of like the modulus. So it doesn't give you an actual float value out of the division. It gives you like a rounded interval.
It should, between Python 2 and 3, it shouldn't have. There is a modulo operator that you might be thinking of. I get confused all the time, so that's absolutely fair. The arithmetic operators here tend to be pretty standard between different languages. The two that I would say tend to change a little bit sometimes are the exponent operator and maybe the modulo operator. Sometimes that's a double percent sign and sometimes not. So, in Python, to do an exponent would be the value that you're trying to add the exponent to, a double asterisk, and then the value, of course, that you're trying to raise, or the exponent. So if I'm trying to square the number 4, it's 4 star star asterisk asterisk 2 equals 16. A modulo operator just gives you the remainder of an operation. So if I were to say 12 modulo 5, let's see, 12 divided by 5, the remainder is going to be 2, right? If I did my math correctly, and I'm not very good at mental math, so I'm hoping that's right. Logical operators are a little bit different between languages, so it's always good to look those up. But in Python, I can use either a keyword or I can use the symbol itself. So when we were talking about Booleans earlier, and I was saying true and true is true, right? I could write that true, the word and true, would evaluate to true, or I could use this symbol here. And it's really just a personal preference that you have as a programmer of which one you want to do. Some people get more comfortable using one or the other. Python uses more keywords than other languages do. And so, I find that people who learn Python as really their first programming language are much more comfortable and gravitate towards the keywords, whereas people who learned programming the hard way tend to use more symbols, and just because we're used to it, and I'm trying to now adapt to a more what you would call Pythonic way of programming, although I'm habitually resistant to change. So I want to talk about for loops a little bit. for loops are what you would call a control flow statement. And again, this is how you iterate over, you iterate the same block of code over a number of elements, right? So this would be just a simple code example of how to iterate over a list, right? So what I have here is I have a list. I'm just storing the integers 1, 2, 3, and 4. And then I'm going to do something within this for loop here. And I want to be able to store my output. So I'm going to make sure that I create an empty list to store it outside of the output, or excuse me, outside of the loop. One thing to be very careful about is there's a difference between what we would call local and global variables. So if you create a variable within a for loop, that becomes what you would call a local variable to that for loop. That means that that variable exists for the block of code that is being operated within that for loop, but it doesn't exist outside of it. So I could define this output within this for loop, but once I exit the for loop, then I no longer have that variable defined. If I define it as a global variable outside of the for loop, then I have access to it after I exit the loop. So that's kind of an important rule of thumb to keep in mind. So what I'm going to do in this for loop, this is a very, I'll show you guys later, there are a couple different ways of writing for loops in Python. This is a very Pythonic way of writing for loops, right? Because it's using all keywords. So the standard syntax for a for loop is the word for, followed by your control statement, followed by a colon, and then the block of code that needs to be executed in the iteration is indented by one tab under that control statement. And the code that I no longer want to have within the iteration block is then unindented. And that's how the for loop ends. So what I'm going to do here in this for loop, I'm saying for lm or element in input. What I'm saying is loop through each element in this input list that I've defined. What I'm going to do is I'm going to square each of those elements. So I'm going to say, I'm going to create this local variable called squared and assign to it the individual element for this iteration, squared, and I'm going to append that into my output list. So what's happening here is that on my first loop, I'm accessing the value 1, which is stored in a local variable called lm. I am squaring that value and saving it as a local variable called squared. And I'm then appending, oh, I should have put squared in there instead of lm. That's an error I'll have to fix. I'm going to append the value squared to my output list. And this is what you should get. Yeah. Anyway, that's how that simple for loop works. So here are a couple of examples of some conditional or if-else statements. I'm not a huge fan of the organization of this slide, so maybe we'll just look at one of these. Let's look at this center one